Hello. In this video, we're going to go ahead and look at determining if the following function or if the following are functions. If it is a function, state the domain in interval notation. So the first thing we're going to do is determine if the following are functions. So we have letters E, F, G, and H here, and this is just really a continuation from the previous video. For letter E, let's look at whether this is a function. To do that, let's look at the y variable. The y variable has an exponent of 1. And because of that, that's odd. That means that, yes, this is in fact a function. Next, let's look at f. X times y equals -6. Now, this is a little bit weird. People tend to think of this as an odd one. And the exponent on the y is a 1, so that's a good indicator that, yes, this is in fact a function. But notice that if we solve for y, we get y equals -6 divided by x because the x is multiplying by the y, so to get it by itself, we need to divide by x. And this hopefully will help you see that, yes, this is in fact still a function. As for letter G, we have y equals x plus 1 to the 1/3 power. And again, the y is here by itself and the exponent is 1, so the answer is yes. This is in fact a function. For letter H, we have y equals x plus 1 to the 1/2 power. And again, the y variable has an exponent of 1, so yes, this is in fact a function. Good. Next, we're going to look at the domains for functions. And in this case, and again, also in interval notation, and in this case, all of these are functions, so we have to find the domain for all of them. To do that, let's first look at letter E. Y equals x plus 2 all over x minus 5. Because this is a rational, we take that denominator, in this case the x minus 5, and we say that it is not equal to 0. And then we just solve it. To do that, add 5 to both sides, so x is not equal to 5. And that just tells me what x cannot be. Everything else is part of the domain. And remember, to do this, the best thing to do is to go ahead and write down an interval notation, or excuse me, a number line. And that means that I can use everything to the left of 5, excluding the 5. I can use everything to the right of 5, excluding the 5 as well. And there you go. Our domain here is going to be -infinity to 5 union 5 to infinity. Notice this is how you take out a single number from the number line. Okay, so this is where x cannot equal the number 5. So it's -infinity to 5 union 5 to infinity. Excellent. Now let's look at letter F. It's best to look at it in this form with the y by itself. So we have y equals -6 divided by x. And to find this domain, we need to look at the denominator because, again, this is a rational expression. So that denominator is an x. And we say that that x cannot equal 0. And it's fantastic. It's already solved. We're done with this already. So if you want to, you can go ahead and draw a number line, put a 0 in the middle. So everything to the left of 0, excluding 0. Everything to the right of 0, excluding 0. So the domain here is -infinity to 0 union 0 to infinity. Wonderful. Next, let's look at letter G. But here's the thing. With G, we have y equals x plus 1 all to the 1/3 power. But remember, a fractional exponent is just a radical. So this would be a radical, and the base is going to be the radicand. But notice that the denominator in the exponent is 3, and that's going to be the index. So this is actually the same thing as y equals the cube root of x plus 1. And so as a result, we ask ourselves, is this an even indexed radical? And the answer is no, because this is a cube root instead of a square root. This is not an even indexed radical. And that tells me that the domain will be all real numbers, negative infinity to infinity. Excellent. Now let's look at letter H. The same thing is happening with H, except this time the exponent is to the 1/2 power. So if we have y equals, and since it's 1/2 as an exponent, that means that we're working with the square root of the base of x plus 1, whatever that was. That was weird. Sorry, x plus 1. There we go. And so we take the radicand, whatever it happens to be, in this case, x plus 1, and say that it has to be greater than or equal to 0. And then we just solve for x. The first thing I'm going to do is subtract the 1, so x is greater than or equal to -1. And again, notice on the number line, put that -1 here, and I shade to the right, but I exclude that -1. And the domain is going to be -1 to infinity and beyond. I'm sorry. I'm really not sorry, actually. Alrighty. Well, I believe that that is it for this particular video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.